Hello everyone, Harry here. Welcome to Scrap Science. A few years ago, I made these three ampules. Now, from left to right, we have iodine, bromine, and chlorine. As you'll note, these are the three easily obtainable or easily synthesized halogens. Now, I like the halogens. I like having these ampules around. They're really nice little element samples. What I don't like is, first of all, this iodine that I made. It's kind of wet. It sticks to the walls of the glass, so it's unable to flow as like a free-flowing powder. A little bit of it does, but most of it is just stuck to the walls. It's nice crystals, but I'd like to redo this. Additionally, this bromine, when I made it, I didn't have the capability of drying it. I didn't have access to concentrated sulfuric acid. So this bromine it's wet again. It sticks to the walls of the glass, and I'm pretty sure there's little bits of graphite in it because I made it by electrolysis with some graphite electrodes. Finally, the three ampules here are all different sizes. I used a large test tube to make this ampule for chlorine gas. I do like this one. This is the kind of size that I want. But the other two, the bromine and the iodine, they're both in small test tubes. So to make it a nice collection, I feel like it would be better to have three ampules that are all the same size. So for those reasons, I'd like to revisit making ampules of the halogens. I think this chlorine one is perfectly fine. I don't like the idea of having liquid chlorine in an ampule. I like having the gas in its natural standard temperature and pressure state. You can actually see the green color of the chlorine if you look closely, which is really nice. But I would like a new sample of bromine, maybe dried and in an ampule that's as big as this one, and then also a new sample of iodine, again, in a bigger ampule. Now, way back when I did my videos on iodine and bromine, I made both of these elements by electrolysis. I love electrolysis, as you may already know, but I've grown up a little bit since then, and maybe, just maybe, not all chemical synthesis has to be done electrochemically. So today I'm thinking we're just going to use some conventional routes to make iodine and bromine, and it'll give me the excuse to try out some of the new glassware that I've got. Now, originally I was actually going to do these three ampules, the iodine, the bromine, and the chlorine, in ampules like this big. I have a bunch of broken addition funnels that I bought years ago, and I thought these would make really nice, really large ampules for the halogens. But first of all, my glass blowing skills are not good enough to like seal this hole at the end or close the joint here to make sure it actually stays sealed. And then additionally, I'm really not comfortable storing this much bromine or iodine. Imagine if this were half full of bromine. I mean, that would be a disaster if that broke, even if you surrounded it with a bunch of sodium metabisulfite to neutralize the bromine. I think it would be a really bad idea. So basically, we're going to stick with these test tubes as our ampules. Actually synthesizing the halogens, specifically chlorine, bromine, and iodine. The others are a little bit trickier, as you might imagine, but making these three elements is as simple as taking their ions, so iodide, bromide, or chloride, and oxidizing them under acidic conditions. Iodine, the one that we're actually going to start with, is the easiest to oxidize. In fact, it's as simple in this case as dissolving up some potassium iodide or sodium iodide, and then adding some concentrated sulfuric acid, which acts to make the whole solution acidic, and also is a strong enough oxidizing agent to oxidize the iodide into elemental iodine. So this should hopefully be rather straightforward. What I've done is I've weighed out about 50 grams of potassium iodide. You can see it's actually slightly yellow due to the fact that I was storing it in a container with a little bit of acidic fumes, and I think the oxygen has possibly oxidized just a little bit of our iodide into iodine, giving it that yellow color. Anyway, first of all we have to do is dissolve this in a little bit of distilled water. We won't need much because potassium iodide is extremely soluble in water. Well, that actually took a bunch more water than I was expecting, but we've got it all dissolved. I've transferred it to a larger beaker. I've got an ice bath ready. We're just going to sit this in here, ready to go. And then, with our sulfuric acid, we're just going to pipette slowly our concentrated acid into our solution of potassium iodide. Sulfuric acid going in. Ooh. You can see some fumes coming off. Might do some stirring while we do this. Alright, I think we're there, finally. The addition of more sulfuric acid does not lead to the same degree of bubbling as before. It's very little to no reaction. Additionally, it doesn't seem to be precipitating any more solid iodine out of the reaction. So I think it's safe to say that this reaction is pretty much done. We've made all of our iodine in here, and all we have to do now is get it out. It's a bit less than I thought it was going to be, but we'll see how it turns out once we purify it. The best way to purify it, of course, is to melt it, boil it, and deposit it on a cool surface. So we're just going to put it on the hot plate, turn the heat up, and if we reposition the camera just a little bit, and also reposition the hot plate, we just put a flask with some ice in it on top, and that will act to condense all of our iodine. You can see already, just after just a little bit of time, we're getting quite a bit of iodine vapor in that beaker. Maybe 5 minutes in, if we take this off the top, we should be able to see we're already getting a whole bunch condensing. Excellent. Additionally, if we get a really close look, you can actually see that the iodine is a liquid at the bottom of our beaker. I do love that purple colour. Very, very nice. And look, we've still got a little bit of iodine hanging out at the bottom of our beaker, but it was starting to spit everywhere, and I'd prefer to keep the stuff that we've actually deposited nice and pure. So if we actually do get that out and have a look, we can see we have quite a nice amount of deposited iodine on that cooled flask. I'm going to scrape it off, I'm going to weigh it, and then we're going to put it in this test tube to ampoule it. A little bit annoying, it is only about 10 grams of iodine. Not sure where all the rest of it went, but that seems to happen with me and iodine syntheses. So we're just going to have to take what we've got, we'll put it in the ampoule and we'll see how it looks. I think it's nearly dry. Well, I mean, it worked. I got it sealed in the ampoule. It could be better, I will admit. We have all of our iodine in here, but it does still seem to want to stick to the glass. I even dried it for 3 days over some calcium chloride in the hope that it would completely dry out the iodine and then it wouldn't stick to the glass. But, I don't know, sticking to the glass seems to be something that iodine just does on its own. It's a lot of fun to shake around because iodine is, of course, very heavy, very dense. Yeah, look, it could be better, but it's a big ampule of iodine, and that's what we wanted from the start. So that's iodine done. On to bromine, I suppose. Making bromine is slightly, as you might expect, more involved than making iodine. It's chemically very similar. We take bromide ions and then we oxidize them under acidic conditions, but due to the fact that bromine is a liquid with a very high vapor pressure, it's best to do this and most efficient to do this in the form of a distillation. We make the bromine and we distill it out as it forms. I have bromide in the form of sodium bromide right here, and our oxidizing system is going to be hydrochloric acid with TCCA, trichloroisocyanuric acid. The combination of these would normally generate chlorine gas, and overall, instead of making chlorine, in the presence of bromide ions, that oxidizing system will actually instead generate elemental bromine, which will come off if we heat up the reaction flask. We're doing nothing new here. We're pretty much just copying a video by NileRed, which I will link in the description. And in fact, for the iodine stuff as well, we weren't doing anything new there either. We were just copying NurdRage's method using the sulfuric acid as the oxidizer. So go check out both of those videos if you actually want to know more about the underlying chemistry. We're just doing this here to make ampules of the stuff. So all we really need to do is mix these three chemicals together in our boiling flask over there. Give it some heat, the bromine will come off. I've got some ice water over here to make sure we actually condense the bromine. I've got a flask over here, or a beaker, that will have a solution of sodium metabisulfite in it to catch any bromine vapors that come off. And hopefully everything should run rather smoothly. And yes, I know some of you right now are looking at your screens. You've noticed something in my distillation setup and you're thinking to yourselves, Harry, are you stupid? You idiot? You buffoon? That is the Graham condenser. Why are you using that in a distillation setup like this? And to that I say, I don't care. I'm going to use the Graham condenser anyway, and there's nothing you can actually do to stop me. Everyone hates the Graham condenser, and I'm pretty sure it was because of like one comment from Tom from Explosions and Fire who said that he really hates the Graham condenser, and then everyone just started believing him or agreeing with him. And I don't agree with that. I think it looks like a nice condenser. I can't say I've ever used it before, but we're going to find out today, is it as bad as everyone says it is? Sure, maybe the liquid will get stuck in the windings, but I don't really care about that. We're going to see how well the Graham condenser works and whether the hate is actually deserved. Everyone says you can't use the Graham condenser horizontally, but you know what? I'm going to live on the edge. We're going to try it today. So just calm down. We can't say whether we like it or not until we try it. To start with, I have our sodium bromide, approximately 50 grams, and our TCCA, approximately 26 grams, in our round bottom flask, ready to be actually distilled. I'm just going to add a little bit of water to this to dissolve some of that up. And to get the reaction going under acidic conditions and actually kickstart the oxidation properly, we have approximately 15 milliliters, maybe a little bit less, of concentrated hydrochloric acid in this addition funnel. I'm going to add this slowly. Again, as soon as things heat up, the convection will get everything kind of stirring around, so it's not too big of a deal right now. And with that done, we've now got a nice darker colour in our boiling flask. I can take out the addition funnel. And we can cap and seal this end of the distillation apparatus. By the way, all of our joints are sealed, or greased, I should say, with concentrated sulfuric acid. And with everything set up for our distillation, we've got our chemicals mixed, we've got our sodium metabisulfite gas scrubber, just in case any fumes come through. Everything's connected up. I've got the ice water. All we need to do is turn on the heating mantle and get the ice water flowing through the condenser. Cool. Just a couple of minutes in, you can see the fumes starting to get a little bit darker. But quite soon we should start to see some bromine vapours boiling off and condensing in the upper parts of the distillation apparatus. Quite clearly, bromine is condensing in our gram condenser. Each time it hits one of these loops, it gets caught in the bottom, but you can see it kind of looping around every couple of seconds. Seems to be working, and it's quite fun to watch, really. You can see actually we're nearly done already. The colour of the fumes above our boiling flask are losing their colour quite a bit. So what's just happening now is we're just flushing out the rest of the system to get all of our bromine down into our collection flask. And our bromine, at long last, is in here. Once again, here is our bromine. The next steps in actually ampouling it all require that I wear a gas mask. We're going to be generating quite a bit of bromine fumes, and I do not want to be breathing that in. So as a result, I'm not going to be able to talk you through what I'm doing as I do it. We're going to have to explain everything now, and you're just going to have to watch as it happens. First of all, the bromine in here, we have the bromine layer at the bottom. We have a bunch of water that distilled over with it. Now, this was expected, but we do have to get rid of the water. We have to separate the bromine out from it. And the way we do that is by pouring it into a separatory funnel. We're going to drain off the lower bromine layer and leave behind the water, which we'll just dump into our bromine waste. And we're going to be draining the bromine into a beaker, which I have here, that I'm going to fill with about 10 milliliters of concentrated sulfuric acid. Now what this will do is it will absorb any water that's left behind hanging out in the bromine, and it will completely dry it. And it's good to have dry bromine when you're putting it in an ampoule, because dry bromine doesn't stick to glass. We're going to give this a good stir once the bromine and the sulfuric acid are in it, to make sure that all of the water is absorbed. A lot of people do that mixing step in a separatory funnel. I don't really like that, because that has the risk of, when you vent it, you can spray bromine everywhere. I prefer to mix it in a beaker. I simply think it's a lot safer, even though it does generate a whole bunch more bromine fumes, hence why I'll be using a mask. We're going to then put that mixture back into the separatory funnel, and then we're going to drain it into this ampoule that I have prepared. We've made a very nice thin neck to make it easy to seal, and then we will blowtorch it and seal it shut. So I'll grab my mask and away we go. Right, I'm really hoping that that has sealed properly. Moment of truth. Doesn't seem to be leaking, and if it were broken at any point, the bromine would definitely find a way to escape. So we can be absolutely certain that this ampule is actually sealed, which is really nice. Wow. Quite a bit of bromine. Now, it's a bit tricky to see in this lighting, but I think a little bit of sulfuric acid actually made its way into our ampule with the bromine, which is a little bit disappointing. You can see just little specks of it around the walls of the glass, but as far as bromine ampules go, I'm pretty happy with this one. And overall, it's 23.7 grams of bromine. I'll give you the yield in percent on the screen right now. It's probably not good at all, but we did get our ampule of bromine. And combined with our ampules of iodine and chlorine, this completes our halogen collection in these nice big ampules. But with that, it kind of concludes the video. We have made iodine, bromine, and in another video we made the chlorine ampule. They're all the same size test tube. Didn't quite get them all the same length, but I don't think that matters too much. They're quite nice samples of our 3 easily attainable halogens, so I'm very, very happy with that. Still a little bit annoyed that the iodine kind of sticks to the glass and the bromine has a bit of sulfuric acid in it that kind of forms these little droplets on the side, but that is our collection and I am very happy with it. So I'm going to go ahead and find a place to store these, outside of course, and until next time, see you later. Oh, also the Graham condenser is great and everyone should use it.